Let me minimize that. Hey, everybody. Welcome to the webinar. I just want to make sure real quick. Can you see everything? Megan is over there. And make sure that stream works. Because if I pull the stream up on my computer, everybody will see the void of streams. Just want to verify it works before I start talking proper.
Yep, we're here.
Okay. All right. So today we're going to be doing a webinar, a Fusion 360 for Makers webinar. Hopefully, if you have the course, you've enjoyed it so far. If not, reach out, and we're here to help you. It's stuff like this extra content that allows you to try to get the most out of your experience in Fusion 360 and for us to help you through that. We just recently launched our Arduino for Makers course. So if you enjoy the delivery style of the Fusion 360 course and you want to expand your knowledge into all things, check out the Arduino course. The first two or three classes are on there for free. It is really great. I don't know that much about programming microcontrollers. Bob did a fantastic job. So today I have a couple questions that people have sent, and primarily I want to show all of you how to take a 3D model and turn it into like a view in your room, like AR model that can be real space. So some benefits of doing this, or you may have seen this. You may have seen this if you go to Amazon and you click on a product. It'll say view in your space, and then you can like stand there with your phone and like, whoa, you can orbit around it and move and see relative scale to the size of your location. So that's what we're going to make. It's pretty awesome. So some ways that this is beneficial. We're making a project right now that is a room scale project. So I have modeled the room. I've taken measurements, I've created parameters, the whole thing that we talk about in the course. And so I have a room modeled of most of the spaces in my house, honestly. But for this one, it's for my two sons, their shared room. So I want to make a bed, and I need to know if it's going to fit. I need to know if it's going to hit the ceiling fan. I want my wife to see it, and I want my kids to see it to know if this is the design that will work. Because as an engineer, I check boxes. You know, I think of criteria, and I tackle those criteria, and the thing that I produce is the most logical way to solve all of the problems. Well, a lot of times that aesthetically doesn't look very good, or it doesn't fit in the space that we're wanting. So I was able to take the model of the bed that I modeled, send it to my phone, stand back in the room, and project it into the space. And so my wife was able to see it in the actual environment, how big it was, if it worked, was it going to cover a window? It was instrumental in being able to make this project work properly. And it turned out that it wasn't going to. So all of my box checking and all of my parameters and all of my perfect modeling, I did everything the way that we talk about in the course, was perfect. It just didn't work. And I wasn't able to understand that by just looking at the model. So if you're going to be doing a kitchen renovation or building a piece of furniture to fit a specific spot, this is an amazing tool to be able to do it, and it is not difficult to do. A few words. I'm going to be using an iPhone. There is a way to do this on Android phones. You have to download a separate app. When this webinar is posted to the course, I will try to get a link. Forby knows how to do it, and Forby's not here because we have been doing this a lot of them for the models that we make plans for. So it is very easy to do on an iPhone. There is like an extra step to do on an Android phone, and I don't know what it is. So I will post that in the description of the webinar later on. So what we're going to do, can you see me in the corner of that, Megan?
Yes, I can.
Okay, cool. So I have my Fusion 360 environment open right now. There's one thing I want to point out, that it is March 23rd at 11:30, and right now Fusion has an unexpected outage. So I'm very glad that I got at least one of the models from my stored database to be able to show you this stuff. But I'm going to model something pretty easily. I'm going to be answering questions, and then I'm going to take the model and I'm going to show you right here on the table that I'm sitting on, the podcast table. I'm going to show it to you in real life and how it works. Because I've got my phone hooked up. We're going to show you. It's going to be cool. So first thing, I'm going to answer some questions that were submitted through the form that we sent out on the Podia email, which is the course. If you purchase the course, you'll get an email there, on social media and the Maker Alliance, all those things. So the first one comes from Quarantine Quartermaster, which is a cool name. He is a teacher, and they have a device that I had never heard of before. It is called the Merge Cube. So it's a 6-sided cube, and each one of them has like a QR code style face. And you can take a 3D model from their library of 3D models and project it onto the face of the cube. And so the students can then take either special glasses or an iPad and move it around. It'll be secured to that face. So it's pretty cool. My friend Wes over at Geeksmithing, he's a great friend of ours and of the channel. He has done similar things where he'll have little QR codes, and when he would Twitch stream, he would have the little QR codes on his desk, and each one of those little codes would project a 3D model on top of it, and it was a super cool feature. But for educating, it's pretty neat. So you can take models of buildings or like dissecting frogs and things, and the students can kind of hold them up and spin them around. So his question about that was, how do you get a Fusion 360 model onto that particular device? So it's specific for that device, but it really is ubiquitous for Fusion 360. It's pretty easy. What you can do is I'm going to show you a model that I created of a book nook. A book nook is a little, I don't know, a little diorama kind of thing that you set in on a bookshelf amongst a bunch of books, and it looks like that the bookshelf goes into something. So I just wanted to see if I can do it and use our laser. So this is the book nook that I made. This is of St. Somebody's Cathedral in Windsor, and it has perspective built into it. And so I built this entire thing. It's made up of several pieces. Here is my browser tree. So the book nook is the highest order. There's the different sub groupings. I made a different one, but this is what it is. And so to be able to export this model, and this is going to come into play later, you can right click on this and you can hit export. And then you have a type. So let me know if, like, I have the paid version because I use this for work. So let me know if the paid version doesn't work the same as the free version. But you can save this as a Fusion 360 file, and there's a couple other different file types here. But you can export that way. But for the particular device that he was asking about, it's asking for an STL, an OBJ, or an FBX file. And for that, you want to right click on the item. So there's this entire item, but I want the front panel too. So the highest, and I'm going to save it as a mesh. This used to be save as STL, which I think in the course it may still say save as STL, but it's save as mesh. And in here, the format, you can choose different formats. So it says save as mesh because the 3MF file type is actually used a lot in 3D printing, and some would argue that it's better. So rather than limiting just to STLs, it opened it up to all mesh types. So you can save it as an STL, or you can save it as an OBJ file. And once you have those files, you can then upload them to the Merge Cube has an online database called the Merge dashboard database. So you can just upload it to that file and then send it to, I haven't used it before, the proprietary viewing software for that particular device. And then it should kind of glue itself to the face of that cube, and you can spin it all around. So you can do that with models that you've made. You can import models into Fusion through STL repositories like we talked about in the course, and you can view them like that. So it's pretty straightforward. It's pretty easy. One thing I really, really like about Fusion is its ability to take the thing that you make and send it wherever you want it. Recently, we were using the CNC yesterday, actually. And so I was able to take a model, and I could take that model, I could export it as an AR in space so that I can see, I'm making a desk, to see if the desk was going to fit, and then I can export that same model and a little bit of cutting selections out to the CNC. If I wanted to 3D print a miniature version to fit into like a little model, I could do that too. It's super versatile, and I think that's really, besides the parametric modeling, the ability to share this model with people, with machines, with different technology packages is pretty great. And that's what we're doing today. So Quarantine Quartermaster, that's how you do that. Right click, save as mesh, select STL or OBJ file, and that's how you go. We have Alexander Volkman asked a question that says, at what age would I recommend starting somebody learning Fusion? I think in the question he had a 9-year-old. My kids are 12 and 8 and 7. My 12-year-old doesn't really have any interest, so I would say just like all things, depending on the interest of the child, like if they're asking about it and if they want to do it, then support that. Like get them a free license and let them go to town, use the course, and make as much stuff as they want to. I would say that this is probably geared toward middle school kids, I think, as a broad kind of shotgun term. But again, there's kids that graduate high school when they were 12, so don't limit somebody who's eager. But I think as a general rule of thumb, like if I had a shop class or like an engineering class in a middle school, I think that this could really be handy in that kind of training and teaching environment. And then the last comment we have from the form that was submitted was from Min Lei. It says, just wanted to say that the Fusion course is awesome. It helped with career growth, which is great. That's one thing we don't really talk about in the course, is that we say it's Fusion for makers, so it's just like this connotation that it's hobby and you can kind of do it in your off time. But like I know professional engineers that are friends of mine that work at major engineering companies that they use a variety of software packages. They'll use SolidWorks, they'll use Fusion, they'll use a couple different ones. But someone asked me about Fusion because they go, it's something that we need to learn in this Fortune 500 company. And I'm like, oh yeah, I know how to use it. I can teach you. And so, yes, it's cool to be in your shop or in your garage and 3D print things or CNC things. But if you are thinking about getting into engineering or some kind of technology field that needs CAD work, like you can take the modeling principles that we have here and you can bring them into Blender and do shading and do camera work and start a visual effects environment. Like it's really a versatile program, and it's a lot more than just like, oh, it's free and I can, cut, whatever you use. I can make a bookshelf. Like you can also make career improvement. So learning Fusion is a great tool to use, and it's an amazing resume bullet as well. But Min also talked about currently taking the Arduino course. So again, that's a nice little pitch for the Arduino course. Go check it out. It's good stuff. And I think the coupon's not still available, right?
No,
Okay.
but we did get another question submitted if you would like it.
I will do those questions.
I'll hold them.
Let me get started modeling something real quick so I can show you the AR function. So what I'm going to model today, it's something super simple. My son needs a pencil holder, and I 3D printed him one that was like round that you would think to put pencils in, and that absolutely didn't work. So I'm going to make like a long rectangular pencil holder that has like a bunch of compartments, and I want to be able to make this on the laser. So again, my engineering mind, the requirements and constraints, it has to hold more markers than any child should have in their grasp at any given time. It needs to hold the dried up markers that no longer work that somehow just get put back in the pencil holder cup. It needs to be laser cut, and I want him to assemble it himself because, there's nothing better than something that you kind of made. So that's what I'm doing. So I think I'm just going to kind of wing this, but here's a pencil. That pencil is probably 4.5 inches tall, so probably about like that. I don't know, I might tape measure. So because I'm going to make it on a laser, I'm also going to make it tab and slot so that he can fit it together. We had a potential product that has not come to life yet that had tab and slot laser cut pieces. So if you're interested in tolerances, like you'll get that here too, because I painstakingly had to figure that out. So the way that I'm going to do that, I always model with the Z up because I think of CNC work and 3D printing. It's easiest to have your model oriented Z up, so that's just how I work. I have my mouse. Now, if you can see the screen here, I have this nice smooth orbit, and that's because I use the 3D Connexion, Connexion modeling mouse. There's one that is way fancier than this, but this one works.
I can link it later.
Yeah, Megan says she's going to link it. So, if you're in the webinar, hopefully you've made it through the course. My toolbar up at the top should look like the toolbar in the course because I think I made them. For brevity, I'm going to talk about what I'm going to do. I'm not going to go through the menu painstaking and find each thing because on my mouse, I have certain hotkeys assigned because I use them the most. And so I just use the hotkey for the center expanding rectangle, which is one of my favorites. So we're going to make the base. And again, I can make this a parameter, but because my design intent right now is to make something kind of on the fly, it doesn't have to be perfect. I've set a parameter for the thickness of the material, not necessarily for the dimensions because we're just kind of winging it. So I think his pencil holder can be about a foot, so we'll do 12 inches. And yes, I'm American, I'm using inches. I love millimeters, but when I think in woodworking, I think inches. When I think in actually designing something, I design in millimeters. So if it's not made out of wood, it'll be millimeters. If it's made out of wood, it's inches. By 12 by 4, sure. So there is the footprint. So one sketch for one element. And so now I'm going to create a, let's do the bottom panel. So the bottom is going to be on the same plane. I'm going to project all that. But then I'm going to create rectangles that are that by my material thickness. So this is one of the parameters that I made. Material thickness there. Oh, Megan brought me my tape measure. Thank you, Megan. So again, this is as quick as I can get it. Tab, material thickness. Man, I only have so much room on my desktop. I like my big monitor where I can model something in real dimensions because the monitor is so big. So these are going to be the vertical walls. This is almost exactly like we did the bookcase. Seems pretty familiar. But what I'm doing here is I want the bottom to tab, or actually I want the sides to tab into it. So I need some tenons on the side, and so I can figure that out. So I want one in the middle. So I'm going to do another center rectangle. I'm going to come out here, and then I get to figure out how wide I want the tenons to be. This is 12 inches long, so we'll do not 2 inch. We'll do a 1 inch, and then we'll just kind of skip. So I want to create a pattern. Now, one thing you may recognize is when you create a pattern, it's kind of a pain to like go back and alter that pattern, especially when it's in a sketch. So what I like to do is create a body and then pattern that, and it's way easier to go back and amend it later on. So let's see how we're going to do this. I'm going to extrude the centerpiece up the material thickness, because again, I just wanted this whole thing done on the laser. I'm going to turn that sketch back on. And then I'm going to extrude, no, that one, and that one. And again, the only reason that I'm doing this is because I want that to eventually interact with all these pieces, but it's easier to do the rectangular pattern like I'm going to show you here when it's a body, because then you can adjust it. So the axis, I want it along the long axis. I want it symmetric. I want it to be spacing. Let's space them, 3 inches apart. And then see, I want that many, so not 3 inches, let's do 2 inches apart. Oh, it's 2.5 inches apart. I can mathematically figure that out, but I'm being lazy. So that looks good. And so now once I have all of those pieces, I need to do one along this side as well. So I can create, man, this is going to take a while. Here, and we'll just do one big one over here. There we go. Megan, do you have some questions? I can answer some questions.
Yoeri asked what was your biggest learning curve with Fusion?
My biggest learning curve would probably be CAM, the CNC work. What's happening here? Because I have learned a different software package to do that. So like I used Aspire and I used VCarve from Vectric. And so having to unlearn that to learn Fusion was kind of difficult because Fusion is very robust and VCarve and Aspire, like they're very good at what they do, but they do one thing. They're CNC post-processing. You can design some and post-process. So that CAM workflow in Fusion took extra steps, and they were extra steps that like I wasn't prepared for, and so it stopped me mentally from doing that. So what I'm doing now is I'm taking all those individual pieces and I'm going to combine them all together into one. And so then if I go back and I change the spacing on any of these things down here, it'll update the model. And so again, we got a bottom. But yeah, learning curve through CAM. Because the big hurdle up front is importing all of your bits. And so it's not like the fun 3D modeling, like you just learn this thing, you want to put it into practice, and it's like, oh, well, stop and go measure this giant pile of CNC bits that you have and then enter them into a database, and then you're ready to go. So there's a lot of upfront work that like I didn't want to do, and I was just being lazy. So, okay, so there's the bottom. I'm going to do the back. I'm going to do it on the same bottom plane. Gonna get rid of that body. Oh, actually, I wanted one of the sketches. And I want to project that line and that line. So now I can extrude. This is the front and the back. We'll make the front and the back different heights. We'll like stair step it, because why not? We can do whatever we want. We're not really building anything. I'll make this 3.5. Sure, that looks good. And so now because I have, I'll go up to the highest level. Because I have these tenons already in here, I can just do the combine tool and cut them away. And then I can add the tolerance, because right now in digital space, those things are completely tangent to each other. But in reality, there's no way that they're going to be able to fit together. So in the course, we created the 3D printing tolerance tester and the laser cut tolerance testers that you can download those files and cut them and make them for this very reason. So now let's get rid of that. Oh, I should have been doing this. Sorry. I'm going to extrude that shape. If I want it stair-stepped, it'll be a little more shallow. So we'll do...
I have a quick question that might be a little bit more time sensitive.
Mm-hmm.
What was the last icon in the toolbar in the create section? I don't think I've seen that before. Richard asked.
Oh, so this is the thing. So
you could
this.
Repeat the question too, since I'm away from it.
Okay, so Megan asked. Somebody asked what the last icon is. This is map boards. So when we talked about creating cut lists, and everybody was like, "What's the thing to create cut lists?" We didn't mention it in the class because that was going to be something that we were going to develop, and that has stalled for quite some time. So for you people that are made it this far in the webinar, it's a Fusion 360 app called Mapboards that works really well. It groups all of the bodies in your model by appearance and by thickness. So if you have a parameter for material thickness and you want that material to be oak, you drag the appearance onto it, and then it will create a cut list for you. So that's called Mapboards. It does cost money. We didn't mention it in the course specifically because, again, we were going to be trying to do something, but we didn't. I just noticed that I missed a piece. So I want that piece too. And so what I did there is I realized that I missed a piece, and rather than like dragging it, I just went back to that function or that activity and fixed it. So there's the, I should just call this sides. Who we kidding? And then we'll extrude the side panels here. Make sure I'm getting the corners because I want the tenons. Boop, boop. Nope, that's not what I did. And we will make them go up to there. I don't want to cut. I want a new body. So it looks pretty boring right now. Everything is overlapping. You can't really make this in real life. So we need to decide where all the tenons are going to go. And so I think I want a tenon right here. It's going to go into the front and into the back. So let's create a new, do short size. And then you can easily move bodies between the two. Now, sometimes it's frustrating that you try to move them and it doesn't let you move, right? You're like, why? Why will it not drag? Why can't you let me be organized? Go down here to your timeline and make sure that the timeline indicator is all the way to the right, and then it should work for you. So with short sides, I'm going to go here, and because they are the same, I'm just going to do it to both of them. I want it to be perfectly equidistant, so I'm going to create a line. I'm going to highlight that line and hit X, which creates a construction line, which means it won't separate your models into two separate pieces. And then I'm going to create a center rectangle, and again, I have a hotkey for that. I'm going to come out here, and so we'll make that an inch. No, we won't. We'll make that 3/4 of an inch. There you go. So this already went out because this piece is already extending. And so what I'm going to do now is, I'm sure that there's a quicker way of doing this. And I'm going to mirror, get out of the way, this guy with the center line because I already have it, which now allows me to just get rid of those. I'm going to get rid of the sides, and now I can drag this all the way. Just get rid of the bottom too, so it doesn't mess it up, and cut it. So there you go. Now I've got 10 ends. So let's turn the bottom back on, which shows me I have 10 ends that I can remove from here. Let's turn the backs on. I have 10 ends I can remove from both of those. And this is pretty boring. And I want this to be, I want it to have dividers. So what I can do is I can essentially just take this same one and I can create a pattern. I don't want faces, I want bodies. This body along this axis. And since I know how far it is, this is 12 minus material thickness. Should line up. So now the two on the far left of the screen are overlapping. We can get rid of that later. But now you can make as many little spots as you want. We'll go with 4. 4 seems good. Okay. So now all of those bodies are here, but remember there's 2 bodies right there, so I can delete one and just remove it. So now I have all those. I have models that can be like subtracted. Now if I really wanted to, I could have like added like a swoop right here, which would have been cool. So let's do that. Let's back up this. And I want to create a sketch. I'm still on short sides, right? Nope, that was wrong. This face, please. And now I have a shortcut for an arc. But before I do that, I need to tell the arc where it's going to go. So I'm going to project that piece. Shortcut arc, which is also in create an arc. I just made a shortcut for it because I like it. Whoa, what just happened? There we go. I'm going to go here to here. And you see that circle with a little line on top? That means that it is tangent to that line, just like that. And I'm going to take this piece. And because the arrow is pointing in the wrong direction, it will be minus material thickness. And I want that to be one body, so I'm going to hit join. Now, looking at this, if I were to build this in real life, this piece would not really be attached right there. So what I can do is I can add another tab. So I'm going to go back to short sides, create another one. I forgot how long this thing was supposed to be. So if you didn't know that, you can hit I and it will measure things, or you can just, if it's just one element, you can just highlight it and it will show the measurement over here in the corner. So it's 3/4 of an inch. We'll do the same thing. So we'll let's project this back line. I have something to snap to. How much room do I have? Let's do 1.5 inches. No. Yeah. 0.75. Come on now. Sometimes it does that. I want a rectangle. There we go. There we go. So now I can extrude this. I'm going to move the body because it might try to mess them up. So minus material thickness, enter, join. There we go. So now I've created this swoopty piece, and if I go back to the timeline and I move it back over, I have all of them. But I did remove that piece when I shouldn't have. So I'm going to delete removing that. So I'm going to get rid of that one. All right, so that makes sense to everybody? Again, when you're doing a pattern, do a pattern on the bodies because you can very easily go back and change this. If I were to pattern a sketch, it's in a sketch and in your timeline. So it's not easy to go in there and adjust things. So I'm going to remove that little stubby one that we didn't want anymore. So now I have all the walls. I've got the bottom. Like, that totally works for what we need. So let's start cutting stuff. Let's get rid of some sketches here. Where's that sketch? What's that sketch? There's another sketch. I got sketches open everywhere. I should be naming these, right? Tell you guys how to do a thing and then I don't do it. So let's just kind of go crazy. Let's do the back wall. I'm going to cut. I want to keep the tool so they don't go away, which is that one, that one, that one, that one, that one, and the bottom. Hit OK. So there's all those. Let's do the front now. That one, that one, that one, that one, that one, and the bottom. Is that it? I think that's it. It looks like that. Hold on. Messed up somewhere. Oh, I know why. Yep. Because those need to be moved up. So if I get rid of the bottom, the problem is I wanted the two on the outside to overlap because they're going to interact with the tenons. The ones in the middle are not. So I can very easily just go change those. You can go back and make some exceptions to the rule, but I can also do this. Minus material thickness. There you go. There. I can also create some tenons in these middle pieces if I really wanted to. I mean, for like mega strength, you can make those go down into the bottom. Like, that's perfectly fine. I think that this is good enough for what we're doing. Yeah. Megan says it can be very strong. I mean, we can, but I think that this is fine. So let's get rid of the bottom. So I need the bottom to interact with these over here. So this one needs that piece cut out. And this one needs the bottom cut out. There we go. So now I've got a little holder for pencils and whatevers. So now I need to set a parameter for tolerance, because I'm making this out of 3mm MDF cut on a laser. The laser has a curve. And so if you cut a pocket and you cut a tenon, the pocket, even if they're the exact same size on the laser, the pocket's going to be way too big because it eats into the material. So a tolerance when I'm laser cutting is not removing material to make space like you would for 3D printing. It's adding material. So it's adding the laser curve back onto it, so then it will be snug. So I'll call this tolerance. I can't spell. Yeah. Nope, tolerance. And this tolerance is 0.12 millimeters. That's the magic number, everybody. That's the one you want. But if you're doing an enclosed space, you want to divide that by 2 because it's going to take that off of all of the sides. So 0.12 millimeters. If you're using 3mm MDF on a laser, that's the tolerance that you need. Okay. So we're going to do this one at a time. The bottom doesn't need anything because it doesn't have any holes. So we can get rid of that. We'll do these. Let's do the sides. So for the sides, I'm going to use the press pull. I'm going to select all these faces. All the enclosed faces right now, because I'm going to do the divided by 2 because it's going to remove it from all of those. And you can, the space mouse again makes this easy to navigate. Let's just keep going. Let's do as many of these as we can. Because I want to go back on the timeline and I want to amend one action. I don't want to be doing extra work. But by doing it this way, I guess I could have created like a tolerance for the mortise and tolerance for not a mortise, like the edge, the ones on the edge. But whatever, this will be fine. I wonder if looking at the space mouse in a video is disorienting. Or if it's going to make people sick.
Possibly.
The space mouse is cool. Once you get used to it, the space mouse comes with like a little game to help you be better at space mousing. So for offsets, you always want to make sure you do a new offset, not the automatic offset. And this is tolerance. Again, divided by 2. Because it is taking... It's a 0.12 millimeters is the tolerance, so it's going to take both of that, and that's 0.24. That's more than we want. So there's all of the pockets, and now we need to do all of the open edges. Ooh, that was wrong. I guess all of these are the same. So it shouldn't be 0.12. It should be 0.06. That's what it should be. So if you're doing this for yourself, don't do 0.12, just do 0.06 because it'll bring in all the walls. Yeah. And I don't want to go, if I updated in the parameters, I would have to, well, yeah. This is where Fusion is cool because whenever you're talking to people and you realize that you did something wrong in real time, you can go back and fix it, or you can just try to make the live go a little bit faster and just like wing it. But that's the beauty of Fusion and your design intent. Your design intent can be very professional and correct the first time, or you can use it as scratch paper and get a product that you're kind of happy with and then go back and make it pretty and make it correct later on. And that's usually what I end up doing.
Someone just said, I wish there was a way to have Fusion 360 use right click like Cura Blender instead of middle click.
Use right click? What do you mean? You can use right click.
I guess it's on like a regular mouse. I don't know. He said, I wish there was a way to have Fusion 360 use right click like Cura Blender instead of middle click.
Maybe to orbit? I'm not sure, but Fusion does have like an entire menu that is in the right click button. I think you can move around with the center click. I think it's shift center click allows you to rotate around, and then just holding the center click allows you to drag. And this is where the space mouse comes in handy because I have the Logitech MX Master mouse, which has like a couple extra buttons, and you can assign those in Fusion to do specific tasks. And so I have these little ones here to allow me to orbit, and one is the center rectangle, but you can assign middle button to do whatever, because when you use the modeling mouse, which also has these 2 side buttons which have menus, you can assign it to do whatever you want. And so it's just a lot faster to do stuff. It's not completely necessary, but it will free up that middle click if you don't want to use it.
He was referring to the orbit.
Gotcha. All right, so we added the tolerance, which again made the mortises, the holes that the tins go into, smaller because it's going to be on a laser. But theoretically, this should work. I can take this piece, and so how I would export this out to a laser. I can use the Mapboards plugin. Let's try it. Mapboards is cool. I'm just going to show you how to use it. So Mapboards, right now the default material is steel, so everything is steel, which is wrong. I'm just going to paint it. So we're going to paint this. We're going to go down to some paint. I like powder coated smooth, so it's not crazy shiny whenever I do a render, and whatever, let's make the entire thing blue. There you go. So I'm going to click on Mapboards. Again, we're going to turn this into an AR model, I promise. So this wants to know the width of like your raw material. So if you're working plywood, this would be the entire sheet of plywood. And so 12 by 4.5, I don't know. Width, let's make this 24 by 16. That's a random number. Hit OK, and it's going to do a thing. And it does that. It creates a map down here at the bottom. And so there is your cut list. And so to send this out to a laser, all the laser software that I use really likes a DXF file or a PDF. And so to be able to get a PDF out of Fusion is not really very linear. So I like to use DXF files. So what you can do is you can create a sketch on any one of these. I project all of the geometry into that sketch. Hit OK. Close the sketch. Where was that sketch? It's up here. And then I save this as a DXF. And then I import that into the laser software as a DXF. Do your speeds and feeds for the laser depending on the material thickness that you want, depending on the laser intensity, and it should cut it out, and those should fit together perfectly into the thing that we designed, right? It's pretty dope. So let's do the thing that you came here for. Let's do the AR. It's super easy. That's why I've been kind of stalling, because it's very, very easy. So here this is. This is our model. I'm going to go to my unsaved. Let's see if I can do this. I want to export. It may make me save it first, yeah. This is pencil holder. But I'm going to use this file right here. This is the thing, the USDZ file. A USDZ file will work natively on your iPhone, which I'm going to show you here in a second. And it's super duper easy. So I'm going to export this. I'm going to put this on my desktop. Export. Like, that's it. So I'm going to go to my desktop. I'm going to find this thing, and I'm going to share it to my phone over AirDrop, because if you don't have Apple phones and you're yelling at me right now because Android, I don't know what Android has, but just send it to your phone. Again, Android, you kind of need an extra thing. So it's on my phone right now. I hit accept. I'm going to show you my phone here in a second when it's done. I'm going to save it to files. It's the native, like, phone. Okay. Boop, boop. Can you hear me now? There you go. Everybody should be able to hear me now, hopefully. So, to be able to move the model, you take two fingers and you pinch it, and it like just made a little haptic like boom, boom when it landed on the surface. So it's on the surface of the table right now. You can move it with one finger. You can swing it back and forth. If you want to pivot it into space, you take two fingers and you like rotate your wrist, like you, and you can spin it. Just like that. So that's sitting on the table. Now, it doesn't understand what's in the foreground and what is in the background, but that's how big the final piece is going to be. And so if I wanted to take a pencil and stand it next to the model, like, it'd be way over here, this is how tall pencils would be. So theoretically, that would work. So again, this is to give you a rough idea of what's going to be in your space, how it would work. Let's try another one. So we're going to get rid of that one. Let's go back to the webinar. Let's move this down and open Fusion back up. Let's use the Book Nook. Let's try it. So
Switch audio back.
it should have automatically worked. Yeah, because I had that on there. So let's go back to the Book Nook here. It might try to do all the pieces. So let's do this. Create church Nook. And I'm going to drag all the good pieces in there. This. Go inside there. Whoop.
Somebody had a quick question. Was that a plug-in for the DXF part?
Nope.
Can you repeat the question?
Oh, someone asked if it is a plug-in to export as a DXF. No, it's not.
Moose also just asked, sorry, may have missed it, what app is being used there, or is it just native?
That is native to your iPhone. So your iPhone has the ability to open the USDZ file type. And that's how Amazon essentially gives it, is it downloads a file, that file from Amazon to your phone, and it allows you to see it in your space. It's just a .usdz file. So if you have an Apple device, it will natively allow you to do it. If you have an Android, there's a file converter. Again, I said this at the beginning, 4B knows how to do it. So I'll put it in the description for the webinar. But all you have to do is send that USDZ file to your phone, open it on your phone, and it automatically works. I didn't do anything special. So we're going to do it in real time. So here's my model. I'm going to right click. I'm going to click export. I want USDZ file. So here it is. Here's your drop downs. Here's a Fusion 360 file. All the rest of these, USDZ, right down there. Now I have the paid version. I'm pretty sure that this is available in the free version as well, because I think 4B uses the free version. If not, then yell at me and let me know. Pick where you're going to put it. I'm going to put it on my desktop. Okay, you can save now. Thank you. Yep. And now, where did it go? There it is, right there. So right here, I'm going to share it, or however you get a file from a computer to your phone. For me, because again, I live in the Apple world, it is easy just to airdrop it. So you can share it. You can email it. I could email this theoretically to everybody who is in attendance or everybody who is watching this, and you can open it, if you have an iPhone again, on your phone, and you could see it in your space in real time. So I'm going to airdrop this to my phone. Nope, that's not me. This is me. On my phone, it's asking me to accept. So I am accepting. And I'm going to go back to OBS and swap over to the phone real quick. I want to open it in Files. Yeah, save it. And so now it's going to automatically try to open it. And then it's going to find a flat surface to put it on. Now, again, the one thing with the USDZ files is the appearances. The appearances in Fusion, aren't that great. This is the smooth powder coating, so I can go into those appearances and try to, turn down the shininess. 4B brought it into Blender and did some shading work. So the things that... This feature is going to be in an upcoming video. The model that we used in the video, he took into Blender and just made the appearances a little nicer. But just... Ooh, Megan, could you go get the actual Book Nook?
Yes, I can.
And set it next to this virtual Book Nook? And we're going to... Oh, man, this is crazy. I made this, and I'm going to set it right there. I'm going to scooch you over. Scooch, scooch, scooch. So we can see if it really matches. I really hope it does at this point. But you can spin around. You can look at the top. You look aside. Maybe Megan just broke it. She screamed. So this Book Nook is designed to be laser cut, just like the pencil thing that we had. Did it break?
No.
A little bit kind of broken?
No.
Let me see. So, let me see. If you could put the corner right where my finger is.
The front corner?
Yeah. Yeah. Whoa! Check that out. I think that that's a success, everybody. I mean, that's pretty crazy. So again, we use this not for desktop stuff. I use this for big furniture pieces to put inside a room to get approval from clients, from my spouse, from myself. I wanted to see in my basement if this is pretty dope.
That's so cool.
Whoa, my hand goes through, but my hand also goes through that one too. So this is super easy. Remember, all you have to do is right click, export, You will choose USDZ file, save it to your computer, send it to your phone. Again, if you have an iPhone, it'll open natively and it'll try to place it right in your space. And if it doesn't, go where you want, you can grab it and move it around, move forward, back. You can pivot it around if you want to. But this is pretty dope. Let's go back to webinar. Whoa.
I have 2 questions if you have.
I would love to answer questions.
Okay. Mat boards. Make sure you read the question. Mat boards, rough cost, and do you need to pay Fusion to use it?
Okay, someone asked about mat boards. No. Just like an app, you pay one time for mat boards. You don't have to pay Fusion. Fusion has an app store. You get to it by going to Utilities, Add-ons, Fusion 360 App Store, and it's in there. It's like $4. There's a Pro version, but we don't use a Pro version. So it's like $4. It's really nice. In the upcoming video where we use this AR feature, again, we're making beds for my boys' room. You see me with a stack of papers that I take to the hardware store. I use those initially, and then we build the thing, and then we build our plans, our really nice looking plans off of the models, the build process, all of it comes together. So we don't use mat boards like as our plans. We make our plans separately, but it allows me to get a rough idea of what I need to cut, how big all the pieces are. This is where labeling all your stuff really comes into play because it'll put the dimensions and it'll put the name. And so when you have a bunch of plywood pieces on a piece of plywood, having your nomenclature right is very handy for yourself.
Cool. Another question, are the plugins found on the Fusion website or in the first page when you open up the app?
I don't know.
Can you repeat that question, please?
Someone asked, sorry.
It's okay.
Can you read it back?
Are the plugins found on the Fusion website or in the first page when you open up the app?
Are the plugins found on the Fusion website? So it's in the Autodesk App Store. So app.autodesk.com/Fusion/whatever. If you go into Fusion, go over to Utilities, click Add-ons, the Fusion 360 App Store is there. Now, the add-ons and the scripts are kind of different. An add-on you can get from anywhere. You can get from GitHub. You can get from a proprietary website. If they don't want to go through the App Store, you can get the add-ons, and they'll have information as to where to put that file. You go into the files on your computer, and you kind of place it there, and then you can run the add-on. Let me see, that nest one might have been an add-on. I had one for the Shaper Origin for a while, but then they stopped updating it. I think that might have been an add-on. But anyway, go to the Fusion 360 App Store, search, what is this called, mat boards. There it is. Oh, so it's not $4. It got more expensive, but that's what we use. And the day that we make our own, I'll go back and I will alter this video and go, the I Like to Make Stuff one. So, but there it is. There's mat boards. The guy that owns mat boards actually wrote me an email. He seems like a nice guy. And his product works. I like it. Okay. So, what did we do today? Answered some questions from the forum that we put out. We modeled something using parametric modeling. We talked about tolerances for laser cutting. We're able to take that model, show it using the exported USDZ file type, and showed you how to view it on an iPhone, how to view it in your space, how to view it on the desk. Again, you're going to see this in an upcoming video where we do this in a room, like using a room scale. It works exactly the same as it does on the desktop here. It's just the model that you're looking at right now, this little pencil cup is, like a couple inches tall, and the book nook is only a couple inches tall, to where in Fusion I have my entire house modeled. So theoretically I could design, I have a kitchen modeled here. It's what I want to redo my kitchen. I can take that kitchen and just project it into my kitchen. Now, if there's things that are larger than the model, it's going to protrude and kind of get in the way, but you can get a rough estimation. You can take an iPad if you want it to be bigger than your phone and just walk around and, fictitiously open a cabinet or reach for a shelf and see if it works. It's super cool. So you might have any other questions for this webinar, either the AR functionality or any of the other stuff that we talked about. I'm here to help. If not, Megan?
And everything else.
Okay.
Good.
Awesome. Well, thank you so much for hanging out for this Fusion 360 for Makers webinar. We'll try to do these more. We've just been really busy making the Arduino course, so you should definitely go check out the Arduino for Makers course that is available on Podia. So if you have the Fusion course, we have a list of products. It should be the Fusion course and the Arduino course. Or follow us on social media. We'll be putting out lots of information about it because we're super proud of it. So again, thank you everybody for hanging out. And if you have any questions, you can send me a message on the course itself. There's a chat function, and I'll usually get an email when I come in the morning, and I'll answer that chat. It might not be in real time because I'm a human being. Or just reach out and ask some questions. So again, thanks for hanging out. And this will be posted in the course. It'll be posted in the course chapters under webinars if you want to go back and view this after the fact. So thanks, and thanks, Megan, for helping out.